This is January 07 question 3. Starting at a time t equals 0, a particle moves from rest along a straight line. A student is given the velocity of the particle at a different number of instants of time. Unfortunately, the student draws a graph with t as a vertical axis and the velocity v as the horizontal axis. This graph is shown below. And there's the graph. So you can see already that this, your usual style of graph would go along here, but this one's actually going up the x or the y-axis. Describe in words the velocity and acceleration of the particle for the following time intervals. So from t equals 0 to t equals 1. So it's as if we have to read that graph this way round, and we're kind of reading it backwards. So it's not a bad idea to turn your page around and see what happens. So if you had a velocity time axis and the graph was going up like that, you would know that would be a constant acceleration. And that's your first answer, constant acceleration. And then from time equals t1 to t2, you can see that if this is a velocity axis, then that's got a constant velocity. And you should always use the word constant in there. And then from t equals 2 to t equals t2 to t equals t3, you can see there that the axes, the velocity values are decreasing, but they're not decreasing uniformly, otherwise it would be a straight line. And so therefore it is decelerating at a non-constant rate. So it's non-uniform. So non-uniform deceleration is your answer there. Write down the equation of motion which describes the velocity of the particle from t equals 0 to t equals t1. Well, what have you got there? You've got initial value of velocity of 0. You've got a final value with a value v. You've got a constant acceleration a, and you know there's a time. So that's v, u, a and t, and therefore the equation of motion is v equals u plus at. Explain how the acceleration of the particle may be determined from the period t equals 0 to t equals t1 from the graph. So again, if you looked at that way, you would be saying, right, acceleration is the gradient of that graph. But the fact that the axis is the wrong way round means we can calculate the gradient of the graph, but acceleration is 1 over the gradient. And so therefore, the acceleration then equals 1 over the gradient of the graph. And that's part A of that question. So part B then is going to ask you to use equations of motion. An athlete runs a 100-metre race. He accelerates uniformly from rest for the first 40 metres. He then continues to run the remainder of the race at the velocity attained after the initial period of acceleration. He completes this final part of the race in 4.62 seconds. Calculate the total time taken by the athlete for the race. So the first bit, there's uniform acceleration, and we're going to use equations of motion. So the first part of the race. So accelerates uniformly from rest. The distance he travels is 40 metres, and we don't know the acceleration, but we do know that he continues at a velocity of, we're going to work that out actually, for the second part of the race. He runs a 100-metre race, and therefore if for the first 40 metres he does this, then the second part he's going to run a distance of 60 metres. He's got a uniform velocity, and the time taken for that part of the race is 4.62 metres. And therefore we're going to do distance as speed by time. We don't need equations of motion there because there's no acceleration. And so it's 60. Sorry, we're looking for velocity, are we?